Have you ever wondered how planners can possibly figure out the future of a city before a single brick is even laid? Well, today we're pulling back the curtain on the incredible high-tech toolkit they use to decode the life of a giant metropolis. Let's jump right in.
I mean, it's a huge question, isn't it? It's something that city planners, like the ones at the Delhi Development Authority, or DDA, have to tackle every single day. And it's so much more than just drawing lines on a map. You're trying to understand a living, breathing organism.
And just to give you an idea of the scale we're talking about, look at this number, 3 crore. That's 30 million people. That's roughly the population of Delhi. Now, how on earth do you even begin to plan for that many people? That's the real challenge. You can't just guess.
So, here's the bottom line. Before you can build anything, you have to see everything. And I don't just mean the buildings and roads you can see with your eyes. I'm talking about the invisible stuff, the human stories, the precise boundaries, the hidden patterns. You need a super accurate picture of it all to build a city that actually works for people.
Okay, so let's dive into the first part of that toolkit, the gadgets and instruments that map the actual ground beneath our feet. And yeah, we've come a long, long way from old-fashioned chains and compasses. First up, we've got the total station. You can think of this thing as the ultimate surveyor's multi-tool. It's a seriously high-tech device that measures both distances and angles with amazing precision, all from one single spot. So here's why it's such a game changer. In one setup, it grabs the X, Y, and Z coordinates, basically building a full 3D picture of a site. It is the absolute workhorse for any construction project, making sure that buildings end up exactly where they're supposed to be, down to the millimeter. All right, we all know GPS, right? It gets you around town. But for professional planning, standard GPS just isn't accurate enough. And that's where DGPS comes in. The easiest way to think about it is like this. It's a fact checker for regular GPS. It uses a fixed station on the ground to catch and correct any little errors from the satellite signal. So what's the result of all that fact-checking? You get centimeter-level accuracy. I mean, think about that. This isn't just a neat trick. It's absolutely critical. The DDA, for example, uses this very technology to draw the super precise boundaries for its massive land pulling projects. When people's property lines are on the line, there is zero room for error. Now let's go from the ground up to the air with our next tool. This is LiDAR. The best analogy is to imagine giving the entire city a CT scan. Seriously. By shooting out thousands of laser pulses, usually from a drone, LiDAR creates a mind-blowingly detailed 3D map of the landscape and everything on it. And what it creates isn't just a picture. It creates something called a point cloud. It's a data set with millions upon millions of individual measurement points. And when you put them all together, they form a perfect, high-resolution 3D model of the city. You can see everything from building heights to the density of trees. It's incredible. And for when you need to get really up close and personal with buildings that are already there, you use 3D laser scanning. This is all about capturing every single intricate detail of a specific building and creating a perfect digital twin of it. This is so important, especially for preserving history. For instance, when the DDA is working on heritage conservation, like with the ancient structures in Meherali, they use this technique. It lets them capture every nook and cranny digitally without ever having to touch a single historic stone. So we've mapped the physical world with some pretty amazing precision. But a city isn't just concrete and steel, right? It's made of people. So now we get to the really fascinating part. How do you map the human story? It really breaks down into two big questions. Physical surveys are all about asking, what is actually there? You know, they're looking at land use, the condition of buildings, the infrastructure. But socioeconomic surveys ask a totally different and maybe even more important question. Who is there? They dig into lifestyles, income, how people travel, and what they actually need from their city. And to answer that who question, planners have to listen a lot. They use primary surveys, going door to door with interviews. They pull from secondary data like the census, and they run specialized traffic studies to understand the daily flow of millions of individual lives. Okay, so we know what kinds of questions to ask, but this leads to a pretty obvious and pretty massive problem. You have all these methods, but you can't possibly talk to everybody. Exactly. There is just no way you can interview all 30 million people living in Delhi. It's physically impossible.
So how do you get a picture that truly represents everyone without talking to everyone? Well, the shortcut isn't really a shortcut, it's a science. It's the science of sampling.
One of the cleverest techniques is called stratified sampling. You don't just pick people at random from a giant list. Instead, first you divide the entire population into meaningful groups, or strata, say by income level, just like you see here. Then you take a random sample from inside each of those groups. It's a brilliant way to make sure everyone's voice is heard, which leads to much fairer planning. Another really common method is systematic sampling. It's super simple, but also super effective. You basically just list out all of the households in an area, pick a random place to start, and then survey, say, every 10th house on the list. It's a clean, unbiased way to get a really good cross-section of what a whole community is like.
All right, so we've covered the tools for mapping the land and the smart techniques for understanding the people. You've got the basics down. So let's put that new knowledge to the test with a couple of quick questions. Ready?
First one, that huge 3D dataset we talked about, the point cloud, is that generated by A, a questionnaire, or B, LiDAR?
You got it. It's B, LiDAR. That's our city CT scan that uses lasers to build that incredibly dense 3D model. Nicely done.
Okay, one more. For that crazy precise centimeter-level accuracy you'd need for property line, would a planner use A, standard GPS, or B, DGPS?
And of course, it's B, DGPS. That's the souped-up system with the ground-based fact-checker. You've got this down. So it turns out a modern city isn't built on guesswork at all. It's built on these deep layers of precise data. Data about the physical world and, just as importantly, data about the people in it. It's a real fusion of high-tech mapping and deep human understanding. Which kind of leaves you with a question. If you had these tools, what's the first invisible story about your own neighborhood that you'd want to uncover?